Okay, this is section 5.7 about inverse trig functions. And we're going to look at inverses of sine, cosine, and tangent specifically. All right, so first, if we look at just y equals sine x, or the sine function, well, because it's wavy, right, waves up and down, in fact, it has infinitely many x-intercepts, well, it itself is not, does not have an inverse. But if we restrict the domain to from negative pi over 2 to pi over 2, notice that is 1 to 1. I don't know if y'all remember 1 to 1 if you use the horizontal line test, right? That's why the whole wave, because the y equals 0 intersects it at infinitely many points, well then it doesn't pass the horizontal line test. It's not 1 to 1. But if we restrict it to just from negative pi over 2 to pi over 2, well then that part is 1 to 1. It passes the horizontal line test and we can find an inverse. Okay, so the restricted domain then is from negative pi over 2 to pi over 2, including both of those endpoints. And the range is going to be from negative 1 to 1. That means we cover all the possible values of the sine function. All right, just from negative pi over 2 to pi over 2. Okay? All right. The domain of y equals sine inverse, that's the way we say the inverse function of sine to the negative 1 power of x, sine inverse of x, is just, remember we flipped domains and ranges? So the range of the sine function will be the domain of sine inverse from negative 1 to 1, and the domain of sine function from negative pi over 2 to pi over 2 will be the range of sine inverse, which will mean the output of sine inverse. Okay, so remember the inputs are going to be values of the sine function. The outputs are going to be values of x or theta. All right, let's practice a little bit. So, how do we want to remember that? So, I look at the unit circle. So, if I look at the unit circle and think of the values of sine function of the sine, those are measured on the y-axis. It's the y value. So, you can measure all the y values on that half of the circle right there. Okay? And so that's your output for sine inverse from negative pi over 2 to positive pi over 2. And that's how I remember, because we're looking at values of y. Okay? We'll do a similar thing for cosine and tangent. All right, so let's try one. Sine inverse of root 2 over 2. So in here, what value of x has sine root 2 over 2? So root 2 over 2 is right there. That's a sine value of root 2 over 2. Remember, this is pi over 4, which has coordinates root 2 over 2, comma root 2 over 2. So the sine is root 2 over 2 for pi over 4. So sine inverse of root 2 over 2 is pi over 4. Notice there's many other places where the sine is pi over root 2 over 2, like, for example, 3 pi over 4, right? But the sine inverse can only give you outputs over here. So that's out of range. That's not in the range of sine inverse. All right, let's try inverse cosine and tangent functions. So note y equals cosine x is also not 1 to 1 for the same reason as sine. So, but if we restrict it from 0 to pi, then y equals cosine x is 1 to 1. There it is from 0 to pi. Yeah, notice horizontal lines, they all cross at only one place on that particular part. Okay, so it is 1 to 1. And so if we restrict then the domain from 0 to pi, then we do have cosine, the inverse of cosine, which we call cosine inverse of x, or arc cosine. And same thing with sine, we can call it arc sine, the sine inverse. All right, so the restricted domain is from 0 to pi, and the range is from negative 1 to 1. So for cosine inverse, the domain is from negative 1 to 1. Those will be the inputs, right? So I can ask, what is cosine inverse of 1? Or what is cosine inverse of 0? What is cosine inverse of 1/2? Etc. And the range is from 0 to pi. Okay? All right. And then the notes also remind us that inverses are mirror images of each other. So you can read that on your own, I think. Let's go on to tangent. Yeah, so remember, tangent is made up of infinitely many noodles, right? But if we just restrict our domain to just one noodle, right, that either falls, or for the tangent, so we'll pick the noodle that goes from negative pi over 2 to pi over 2. Yeah? if we pick that, then y equals tangent x is 1 to 1 and does have an inverse. Again, it'll be called tangent to the negative first power of x, or tangent inverse of x is the way we say it. Or we can also say y equals arctangent of x. Okay. The restricted domain is from negative pi over 2 to pi over 2, and the range is from negative infinity to infinity. The domain of sine inverse is then from negative infinity to infinity, and the range is from negative pi over 2 to pi over 2. Okay, so let's go back and talk about, remember we did the little circle thingy here to determine where our arc sine is going to have numbers on, or values, or a range. So for the cosine, that measures values of x, and so you cover all the values of x for the cosine on that half of the circle, so from 0 to pi, right? For tangent, it really follows the sine, right? So for tangent, you cover all the possible values of the range from negative pi over 2 to pi over 2, just like the sine, okay? So that means when we ask for tangent inverse of a number, your answer, right, or the output has to be there. Same thing for the sine, and for the cosine, our cosine of any input has to be somewhere in here, from 0 to pi. All right, so let's take a look at maybe one of these. So arctangent of 0, that means where the tangent is 0. So sine is 0, or sine is 0, right? So sine is 0 right there. So arctangent of 0 is 0. Yeah? All right. We'll do the other two in class. All right. Approximate inverse trig functions on a calculator. So let's take a look at the kinds of questions. Let's read this. Recall there are domain restrictions on the trig functions that make possible the corresponding inverse functions. Okay. So approximate the function value in both radians and degrees. Sine inverse of negative 0.81. Our cosine of 2/7, and tangent inverse of negative 7.92. Okay, so we're going to use a calculator. All right, and you'll have to find your arc cosines, arc sines. So on my calculator, the arc cosine is right above the sine. It's in an orange button, so I press the orange button there. It's like the second button. So let's do the first one, sine inverse of negative 0.81. So negative 0.81 is a value of x, 0.81 negative, and I'm going to take sine inverse, which is the orange, and that's negative 54.09. So that is degrees. So it's negative 54 degrees. So negative 54 degrees, let's call it negative 54.1, 0.1 degrees, or 0.10, whichever one, okay? How about radians? Well, first I need to put my radian mode. There's my radians right there. Okay, and I'm going to type in the same thing, 0.81 negative arc sine. And this says 0.944, negative 0.944. So notice I already said degrees right there. Okay, so I can say negative 0.944. And if I don't put degrees and I don't put anything, that's radians. Okay, let's try the other number one, the second one, right? It says approximate the measure in both degrees and radius of the angle theta with the given conditions. Okay, so it says, let's try the first one. So it says sine theta equals negative 3/7, and theta is from 180 to 270. So let's find out what this says. Okay, so first of all, I'm going to use arc sine. Notice they're not asking me to find arc sine, but I'm going to use arc sine. Remember, arc sine is going to give me a value right here from negative pi over 2 to pi over 2, or from negative 90 to positive 90. Notice that I'm asked to find theta from 180 to 270, and that's okay. Let's find it first from negative 90 to positive 90. So let me change this to degrees. Degrees. All right, and negative 3/7, so 3 negative divided by 7. There it is. And I'm going to use arc sine just to give me a starting point. Negative 25.38 degrees. So negative 25.38 degrees. Now, I'm going to just mark that where that is on the unit circle. So negative 25 degrees is going to be about right there, This is negative 25.38 degrees. But an angle that corresponds to that, that has the same value of sine between 180 and 270 would be over here. It's the same sine value, right? Right there. How do I know that? Well, because this is cosine sine, right? So sine right there, it's the same sine value. All right, but what number is that? Well, it's 180 plus 25.38. So I'm going to add 180, and that gives me 205 point, I'm going to say 4 degrees. So 4 degrees. So 205.4 degrees. 205.4 degrees. Okay? All right, let me pause here a second. All right, I've paused. All right, and we're going to continue the other part, the next page, on the next video. So this will be the end of part 1, and then we'll continue this on part 2.